systems of equations. So we're gonna start talking about systems of equations in this chapter. Systems of equations is when we have two equations happening at the same time. And what we're looking for is what is the ordered pair that makes both of those equations true at the same time. So if we graph one equation that has two variables, we're going to get a line, and that line has an infinite amount of ordered pairs on that line. If we graph a second line and those two cross each other, there will be one point that has a solution to both of those equations at the same time. So in this chapter, we're going to be looking at multiple ways of solving what we call systems, more than one equation, of equations. We're going to start by using graphing. So we're going to come back to we're going to be graphing turkeys here. This is technically a Thanksgiving themed one here, but we can have turkey any of the time of the year. So we're going to be graphing turkeys. So what you'll see on the right side of your paper is two equations in a box. I've spread them out here so I can kind of show my work. You can use your dry erase board or a regular sheet of paper to put out some work so you know what you're graphing for each of these. We've talked about three methods of graphing. So make a table, use slope-intercept form, or the intercepts. You should be flexible with all three of these and be able to decide which one works best looking at an equation for you. It doesn't have to be the same method that someone else uses, no, but you should be pretty flexible with that. All right, so we're going to graph these two equations and we're going to see where they meet on this worksheet. They should meet at one of our turkeys here. All right, so this one is in slope-intercept form, which works out really nicely. So I'm going to take a look at my slope and I'm going to take a look at my y-intercept. So my y-intercept here is -6 and my slope is -2/3. So I'm going to graph this line on this coordinate plane. Now, one of the things I want you to pay attention to as you're graphing with systems is we're looking for a very specific point. We want a very specific ordered pair where the two meet. So please don't draw 3 or 4 points and then just grab your ruler and draw a line. You want to actually leave yourself a trail of breadcrumbs across the coordinate plane until you find the exact point that the two meet. All right, so I'm going to start here at -6. So let's see, 1, 2, 3, 4, 5, 6 down here. I've got a rise of -2 and a run of 3. So I can go down 2 and to the right 3, or I can go up 2 and to the left 3. I can go either way. So if I'm starting here, I might want to be going, I've got a negative slope. So I might want to go this way, down and to the right, or I might want to go this way, up and to the left. I'm not sure which turkey I'm going through here. So let's start with down 2 and to the right 3. So down 2, 1, 2, 3. I'm going to leave myself a point. Down 2, 1, 2, 3. Down 2, 1, 2, 3. Down 2 to the right 3. Down 2 to the right 3. Down 2 to the right 3. Down 2 and to the 1, 2, 3. All right, so there we go. So this one goes through this turkey down here. So I've got my turkey. This one goes through here, but I don't know where the other line goes, so I want to continue that line. So I'm going to go up 2, 1, 2, 3, 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 up 2, 1, 2, 3. So this one comes up here. So I actually don't know which turkey the other line goes through. So I'm going to leave this one right where it is. I am going to grab your ruler, and I'm going to do a nice long line here. Whoops, that one's off. I am going to suggest maybe you use colored pencils, that you draw your two lines with two different colored pencils so you can tell which one which. Or if you want to do one system in one colored pencil and then do the next, actually makes more sense. Do two lines in the same color and then grab a different colored pencil for the next two set of lines. And I believe also for this worksheet, I've done it on the front and on the back. So if you get a couple of systems on one side, then you want to flip to the back side and do the rest of them because it can get kind of filled in on that graph. All right, so next I'm going to graph this line here. All right, so this isn't standard form. So I could think about my intercepts here, but I'm already looking and noticing that if I divide by 2, that's going to be a decimal. So this is actually pretty easy to get into slope-intercept form. So I'm just going to rewrite this in slope-intercept form here and work from there. again, I want to be flexible to decide which method is going to work the best with this particular equation. So I know my slope is -2 over 1, and my y-intercept is 21. So my y-intercept is way up here at 21, and my slope is -2 over 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So again, I want to keep going. And again, a trail of breadcrumbs. I don't want to stop in the middle. And there we go. And just assume things. Again, it goes through it looks like it's going through the pot of this turkey, but I'm not looking for which turkey it goes through. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. There we go. Those two run into each other. All right, so these two are meeting up over here at this turkey. And I want to be very specific about where they end up. I want that particular ordered pair. So that ordered pair is a solution to both of these inequalities. So if I come down here, down 2 and over 1, I've got 20, and I've got, oh, I can't even read that, that's so small. But this ordered pair, if I plug it into both of these equations, it should make it true. So on your worksheet, you should see this turkey guy here. What is he? He's the one with he's our violent one who's got the gun. You're going to fill in this systems of equations for that turkey because they meet at that particular spot there. So our systems equations, solving by graphing.